Today we are studying the cool temperate continental or Siberian climate, the Great Northern Belt. This is one of those topics students usually reduce to one line. Very cold climate, conifer forests, lumbering. That is incomplete. You need to see the full chain. High latitude plus continentality creates the climate. The climate selects the vegetation. The vegetation shapes the soil. And the soil and forest together determine the economy. Once that chain is clear, this chapter stops being memory work. So, where exactly is this climate found? Only in the northern hemisphere. The main belt runs across subarctic Canada, Scandinavia, and Siberia, where it is also associated with the taiga belt. Now lock the real reason. This climate needs large continental interiors at high latitudes. Land must cool intensely in winter, and that requires width and continental mass. This is where most aspirants lose marks. If an option places this climate in Patagonia or New Zealand, eliminate it. Southern continents are too narrow at high latitudes to generate that same continental cooling effect. Now define the climate through its extremes. Winter is brutally cold, around -30 to -40 degrees Celsius. Summer is brief and cool, roughly 15 degrees Celsius. That gives you the first defining feature, extreme annual range of temperature. And the second is duration. Winter is long, bitterly cold, and well below freezing. Summer exists, but only for a short window. The third clue is the effect on water bodies. Rivers remain frozen for as much as 3/4 of the year. Frost can arrive as early as August, and by September, lakes may already be icebound. This is not just cold weather. This is a climate dominated by continentality. Now comes the paradox students often get wrong. This region is cold, but it is not highly wet. Total annual precipitation is only about 40 to 60 centimeters, which is low. And the reason is simple. Cold air has low moisture holding capacity. That is why, even when snowfall happens, total precipitation remains limited. The seasonal pattern also matters. The maximum rainfall tends to come in summer, mainly as convectional rain. Now the trap. Heavy snow does not automatically mean high precipitation. And permanent snowfields like the Himalayas are absent here because the summer, though short, is warm enough to melt the seasonal snow. So remember the logic. Cold air, low moisture, low precipitation. Now meet the vegetation that survives this climate. The conifer. Conifers dominate because broadleaf trees cannot handle this combination of bitter winter, short growing season, and poor soils as effectively. And the key commercial feature is this. They occur in pure stands. That means large stretches are often dominated by a single species, unlike tropical forests where species are highly mixed. In the colder north, the main trees are pine, spruce, and fir. Further south, where conditions are slightly milder, larch becomes important. This one distinction matters because vegetation pattern here is not just ecological, it is economic. Now look at how the tree itself is engineered for survival. The conical shape helps snow slide off, preventing branch breakage. The triangular profile reduces resistance to strong winds, and the thick bark acts as insulation against excessive cold. So this is not accidental appearance. This is structural adaptation. If a plant survives here, it must survive weight from snow, strong winds, and prolonged freezing. That is why the shape itself becomes a climatic clue. Now the leaves. Conifers don't carry broad leaves. They carry needles. Needle shape reduces surface area, so transpiration loss becomes minimal. That matters because even in a cold region, moisture can still be limiting. Then comes the waxy coating. That coating helps retain moisture in dry, cold winds. And then the third advantage, evergreen nature. The tree does not waste time growing fresh leaves every spring. The moment temperatures allow, photosynthesis can begin. And one detail you should retain, needles can remain on the tree for as long as 5 years. That is efficiency. And in this climate, efficiency is survival. Now the soil reality. This is where the climate becomes an economic limit. The dominant soil is podzol, an ash-gray, acidic, infertile soil, usually with a darker subsoil below. How does it form? First, tough pine needles fall. Second, cold conditions slow decomposition. Third, leaching remains high and humus stays low. The result is acidic, nutrient-poor soil. And that leads to the final line that matters. Agriculture is nearly impossible. This is one of those classic geography chains UPSC expects. Climate affects vegetation, vegetation affects soil, soil affects land use. Now we shift from ecology to economy. This coniferous belt across Eurasia and North America is one of the world's greatest sources of softwood. Softwood is commercially valuable because it is workable, abundant, and ideal for pulping. And the industrial geography is worth remembering. The USA became a major producer of wood pulp. Canada became a global leader in newsprint, with the slide highlighting about 50% of world production. And the USSR emerged as a major timber exporter. This is why the belt is called green gold. Now understand why lumbering becomes the dominant occupation here. Compare this with tropical forests. Tropical forests are heterogeneous. Species are mixed, extraction is difficult, and commercial harvesting is more complex. But the Siberian or taiga forests are homogeneous, pure stands of similar trees over huge areas. That makes mechanical harvesting easier, faster, and more profitable. So the real commercial advantage is not just the presence of forest. It is the combination of single-species belts plus large-scale extractability. That is why lumbering becomes the most important occupation. Now take the timber into industry. The chain is straightforward. Logs become softwood timber. That timber goes into chemical and mechanical pulping. From there, major industries emerge. Paper and newsprint, especially in the USA and Canada. Matches, particularly associated with Sweden. And chemical products such as rayon, paints, and disinfectants. This is the part students skip. They remember forests but forget industrial applications. UPSC does not. Now go beyond timber. Another important activity here was trapping. Large-scale extraction of fur-bearing animals such as muskrat, mink, and fox for export. That happened because where agriculture is weak, people turn to what the environment still offers. And agriculture itself is the exception, not the rule. In the far north, it is almost impossible. Whatever little farming exists is confined to sheltered valleys bordering the steppes. The crops are limited and mostly for local needs: barley, oats, rye, and potatoes. So if a question asks whether this region is a major agricultural zone, the answer is no. Timber dominates. Farming survives only in pockets. Now compress the whole topic into one logical flow. Cause: high latitude, around 60 degrees north, plus strong continentality. That produces a climate of long bitter winter and low moisture. That climate selects vegetation: conifers, needle leaves, conical shape, evergreen habit. And that, along with poor acidic soil, shapes the economy. Very little agriculture, but major lumbering. This is how you should remember the chapter, not as isolated points, but as a causal chain. Now, the final exam checklist. First, geography. This climate is absent in the southern hemisphere because the land masses there are too narrow at high latitudes. Second, vegetation. Pure stands are the reason commercial lumbering succeeds here. Third, soil. Acidic podzols are poor and unfit for serious agriculture. Fourth, industry. Associate Sweden with matches, Canada with newsprint, and the USA with pulp. If these four anchors are clear, this topic becomes easy marks and you are exam ready.